Hi everyone. In today's video, we are looking at what are the dimensions that you rate a particular response on. And these are the 5 dimensions that we discussed earlier. So the first dimension that we have is called instruction following. The second one is called accuracy. The third one is called optimality and efficiency, up to date, and presentation. So out of these 5 categories, only the top 4 categories actually qualify a particular response for a deviation in the model. If the issue is just with the presentation, in that case, that particular response cannot qualify for a deviation in the model. So let us discuss what exactly are these categories and what is the difference between them. So for instruction following, basically what you are checking for is if the model is even attempting to do what the user asked it to do. Is the model following the instructions present in the user query? However, correctly it is following that comes under accuracy. So in accuracy, you check for whatever the model is doing, is it doing it correctly or not? Optimality and efficiency is basically then whatever code that the model is producing, how optimal and efficient is that particular code? If it is following the common best practices and standards, etc. That comes under optimality and efficiency. Up-to-dateness is basically if the model is using the up-to-date versions of any particular libraries or any particular modules, if it is using the up-to-date version of any particular API, for example. In that case, any issues with that might cause either a deprecation warning or full-on code errors itself. In that case, both of those cases should be marked under up-to-date. Out of all of these 5 categories that we have here, if there is one particular issue in a model response, it can either belong to only one of these categories. The last category that we have is called presentations. So in this category, you check if the response is following certain presentation guidelines, if it has a professional tone, if it has enough comments in the code, if the answer is concise and not very verbose in nature, if the response is presented in bullet points instead of big, bulky explanations. So this is what comes under presentation. Now, let us look into what is the difference between instruction following and accuracy. And this is a really important concept. And in order to explain this to you, I actually have a story which I want you all to go through. So this is me and this is my little brother. So as the responsibility of all big brothers go around the world, we cannot let our siblings be happy. So one day my brother was sitting in his room. He was watching some streamer play some video games or etc. I barge in his room and I say that, hey, go bring me a banana. He was sad, but he knows that he can't defeat me. So he says, okay. So he goes to the market. He comes back and this is what we have. He got me a banana. He also got me an apple. So in this case, did he follow my instructions? I'll give you 5 seconds. And the answer is yes, he did follow my instructions. I asked my brother to bring me a banana. He got me a banana. I did not restrict him to only give me a banana, in which case my brother did follow my instructions. He also got me an apple. Maybe he got me out of his own love for me. That is very unlikely, however, but we'll keep that aside. He did follow my instructions here. So now again, my brother was sitting in his room. He was playing some video games, etc. I again barged him. And this time I asked him to get me a peeled banana. He was sad again, but he has to comply with what I say. So this time around, the space-time continuum actually breaks. And there are 2 parallel universes that are born from this point. In one of the parallel universe, my brother comes up to me and he says that, hey, here is your peeled up banana. And when I look at what he got me, the banana is actually cut up into different slices instead of being peeled. So in this case, is it accuracy or instruction following? The answer is, in this case, it is accuracy issue. It is because my brother says to me that he has peeled up the banana. So in his small mind, he thinks that peeling up the banana is actually cutting up the banana into different slices. So he does not know what peeling up looks like. This is why this is an accuracy issue, not an instruction following issue. In the other parallel universe, the same thing happens. But here my brother says to me that here is what you asked for. So in this case, however, this is an instruction following issue, because when this thing happens, the first thought that comes to your mind would be, did you even listen to me when I asked you what I needed? It is possible that my brother went to the kitchen. He forgot what I asked him to do. He remembered that it had something to do with a banana. And he just cut up into different slices instead of peeling it up. So in this case, this is an instruction following issue and not an accuracy issue. The moral of the story is, what the model says it is doing is the key difference between instruction following and accuracy. If the model says it is doing something, but it does not do that, that is an accuracy issue. But if the model does not say it is doing something and also does not do it, that then becomes an instruction following issue. So this is the core difference between instruction following and accuracy. And this is really important for you to understand. A majority of the questions that you're going to see in the test after this course are going to be related to instruction following and accuracy. So now let us discuss what is the difference between a minor issue and a major issue between these dimensions. So in the instruction following dimension, a minor issue is when, let's say, you provided the model with 10 constraints and the model forgot to follow 2 or 3 of them, but you still got primarily what you wanted the model to do. It's just that a couple of constraints were not followed. So in that case, that is a minor issue with instruction following. A major issue would be, let's say, if you ask the model to create a website, but the model only created the front end part, not the back end code. So in that case, that then becomes a major issue because the primary request of your prompt itself was not fulfilled. In this case, this is a major issue in instruction following. Next up, let us discuss what is minor versus major issue in accuracy. So a minor issue in accuracy could be any low risk security issues, any inaccuracies in the statements that the model is providing. For example, let's say if I ask the model to create a website and I specifically ask the model that, hey, I want the website with a yellow background. And it turns out that the model responds to me and he says that, hey, this is the website with a yellow background. But when I open the website and when I test the website, it turns out the background is not yellow, it is kind of orange. So in that case, that is a minor issue in accuracy because the model stated to me explicitly that it is creating a yellow website, but it is possible that the model does not know what is the hex code of the yellow color. So in that case, it is a minor accuracy issue. If the model makes any unproven claims or statements, that again comes into minor issues with accuracy. A major issue in accuracy always comes when the code itself does not work. If there's any issue that causes the code to go into errors, maybe it could be a logical error, it could be a runtime error, it could be compile time error. But in any case, if the code is not running, that would be considered under a major issue in accuracy. The third category that we have is called in optimality and efficiency. And here the difference between minor and major actually comes from the point of reference of the ideal code itself. For example, if the ideal code of that particular prompt would have had a time complexity of, let's say, order of n log n, and if the model produces a code which has a time complexity of order of n square, in this case, the difference is not that much, but the model still did not produce the most ideal code. In that case, this is a minor issue. A major issue could be if the model is producing a code which has a time complexity of order of nq or even more than that. So in this case, the code that the model is producing is really inefficient. It is not at all optimal for this particular query. In that case, it is a major issue in optimality and efficiency. Now let us discuss what is the difference between minor and major in the presentation category. So in presentation, a minor issue comes when your variable and function names are not well defined. If instead of writing bullet points, it is written in paragraphs. If the model is using inconsistent backticks or camel casing and snake casing, etc. There are a lot of smaller points that go into a minor presentation issue. A major presentation issue is when the code entirely lacks any comments inside of it. The response is very unstructured. For example, some part of the code is here. There's some description, then again some part of the code is here. So in this case, the end user is not able to keep track of the flow of the response itself. And it is really hard to understand what the model actually did. So in this case, that then becomes a major presentation issue. Finally, we have the last category, which is called up to date. So this is where if the model is using an out-of-date library or an out-of-date implementation of a particular library, or if the model is using a deprecated API, etc. In this case, the code should be marked under out of date inside the up to date category. So these are all of the 5 dimensions that we discussed. In the next video, we are going to cover what is the preference scale using which you choose the preferred response between the 2 responses. So stay tuned for that.